Hi everybody, welcome to this video. My name is Joey. I'm Thinque Prep's resident math guy. And in this video, we're going to be looking at the 2019 free response question number 3. And it was the same question on both the AB and the BC exam. So for part A, we're given this lovely graph on the left, and then we're told that the function goes from -6 to +5, even though the graph only goes from -2 to +5. And then they give us a few other things about the graph. It says there's two line segments. There's a quarter circle centered around the point 5, 3. So we know this is the center of our circle. And it's known that the point 3, 3 minus root 5 is on the graph of f. So we are given that point too. And then the question goes, if we have the integral from -6 to 5, and we know that that's equal to 7, find this integral that goes from -6 to 2. And if you remember, the geometric way of interpreting the integral is the area under the curve. So we're trying to find the area there. And what's the really rude part about this question? We don't have the graph that goes from -6 to -2. So here's the theorem that we need to use. We need to know that if we have an the integral of an interval, we can split up that interval into two subintervals, A to B maybe, and then B to C. So long as these two numbers match. And for those of you who are more visual learners, let's think about it this way. So let's call this A, let's call this B, let's call this C, and let's call this my lovely squiggly curve. And I want to find the area from A to C. If I don't have enough information to find the entire integral, I can split it up into two subintegrals, right? So this would be the area from A to B, and then this from here would be the area from B to C. So you can split it up this way. And if we want to write it for this question then, we would say that the integral from -6 to 5 of f of x dx equals the integral from -6 to -2 of f of x dx plus the integral from -2 to 5 of f of x dx. And in fact, the scoring guideline gives you a point if you write out this expression in some way, shape, or form. So the next part we need to do is we need to start calculating the area under the curve. So there are a multitude of ways that you can actually calculate the area. I'll show you my method of doing it. So we have this triangle right here, right? Well, this triangle is actually equivalent to this triangle right here. So these areas cancel out and have a net space of 0. Same thing over here. This half triangle here and this half triangle here, they also cancel out. So actually the area from -2 to 1 is equal to 0. The next step is we need to calculate this part. So we can make a trapezoid over here. And from part 2, you should remember that the area of a trapezoid is 1/2 base 1 plus base 2 times the height. What's the base 1? We can call this our base 1, so that'll be 1. What's base 2? We can call this bigger vertical line our base 2. And the height is the distance between the two x values. So that's equal to 1. 1/2 times 4 times 1 is equal to 2. So that's the area of our trapezoid. And then the next part is going to be a little bit harder to figure out. We need to figure out what this area is. So if we use geometry, we can see that there's this big square over here that lines up with the center of the circle. And so what we want to do to calculate this shaded region is to take the area of a square and then minus a quarter circle. So this square is going to have dimensions 3 by 3. So then we'll just call that 9. And then the area of a quarter circle is pi r squared over 4. Since the center is 5, 3, we know that our radius is 3. So then the area of this triangle is equal, the area of the curve under the semicircle is 9 minus 9 pi over 4. So then we've figured out this component then, the area from -2 to 5. And then we also know the area of this component, right? So we can start plugging things in. So we know the left-hand side is equal to 7. We're solving for this integral, so we'll just rewrite this over here. And then if we were to plug in our value, what will we get? We get 2, which is the area of the trapezoid, plus 9 minus 9 pi over 4. So then to balance both sides, we'll minus a 2 minus a 9 plus a 9 pi over 4. So then we get that the integral from -6 to -2 is -4 plus 9 pi over 4. And that's your answer. So in this part, we're told to evaluate this integral from 3 to 5 of 2f prime of x plus 4 dx. So one of the properties of integrals is that if we have a sum inside the integral, we can split it up into the sum of two separate integrals. So what do I mean? I can take this as 2f prime of x dx, do not forget the dx here, plus the integral from the same bounds, 3 to 5, of 4 dx. Because then this becomes much easier to evaluate. Furthermore, we have this constant coefficient that we can pull out in front of the integral. So it'd be 2 times the integral of 3 to 5 of f prime of x dx plus this integral over here. And then we get to use FTOC, the fundamental theorem of calculus. That is, if we have the integral of the derivative, we can rewrite that as the original function at the top bound minus the original function at the bottom bound, FTOC. And then let's integrate this thing over here. The integral of a constant is just that constant times the variable from 5 to 3. And now we need to reference our handy-dandy graph to figure out what f of 5 is. Well, f of 5 is this point right here. The y value of that point is 0. So we know f of 5 is 0. And then f of 3 is this point right here, which would be impossible to calculate except we have this point. I take that back. It wouldn't be impossible. It would just be very, very difficult. And so remember that when you have this point, to plug it in parentheses, because I can see some of you doing a distribution mistake and then not getting the final point. And so 4x, we want to integrate 4x, we're just going to plug in the bounds, 5 minus 3. And honestly, if you wanted to, and you're scared of making arithmetic mistakes, you could just leave the answer in this form. But I'm kind of a masochist, so I'm going to do all the work and simplify. So it's 2 times parentheses -3 plus rad 5. 4 times 5 is 20. 20 minus 12 is 8. Don't forget to distribute this 2 now, so it's -6 plus 2 root 5 plus 8. And then that's finally equal to 2 plus 2 root 5. Don't be a masochist like me. Part C, we're given the function of g is given by g of x is equal to the integral from -2 to x of f of t dt. Find the absolute maximum of g on the interval -2 to 5 and justify your answer. So let's look at this equation over here. What is this equation saying? The function g is the integral starting at -2 and then ending at some unknown x point of this function over here. So basically, g depends on the area under this graph right here. In order for us to solve this problem, we can use the fundamental theorem of calculus, part 2, which says that if g is the integral of f, then we can say the derivative of g is just equal to f of x. And actually on the scoring guideline, they give you a point just for writing this statement over here. So make sure you make a habit of doing that. Whenever you see that one function is the integral of the other, you can also write that the derivative of the first is just equal to the second function. Now we can move on to the second sentence, which is saying find the absolute maximum. Well, in order for us to find the absolute maximum, we need to evaluate our critical values. When do our critical values occur? They occur when your derivative, in this case f, is either equal to 0 or when your derivative is undefined. So let's look at our graph here. Where is our graph equal to 0? Well, I have a point right here at -1, this one at -1/2, and then we have this one at 5. So we can start making a t-chart now, because that's usually the easiest way to evaluate absolute maxes or mins. And then we're just going to evaluate the different values. So in addition to evaluating our critical values, we need to test our endpoints. So our first endpoint is -2. We have a critical value at -1. We have a critical value at +1/2. And then our final value is when x is equal to 5, which is our endpoint. And so how do we calculate g? Well, we need to use the area starting at -2. So let me just go ahead and split up my figure into different areas bounded by the x-axis. This one is a triangle of dimensions 1 by 1, and this is going to be +1/2 since it's above the x-axis. Let's do this triangle over here. We'll treat this as the base. The base is 1.5. We'll treat this as the height. That's 1. So 1/2, 1 times 1.5, which is the base, is equal to 0.75. But since it's under the x-axis, it's negative. We have another triangle to test right here. This is the base of this triangle. This is the height of this triangle. This triangle has a base of 1.5. This triangle has a height of 3. So 1/2, 1.5 times 3 gives you a positive 2.25. And then we have one more area to calculate. We actually did this in part A, so I'm not going to redo this work over here. But this area right here is 9 minus 9 pi over 4. So given that we split up our figure, we can start accumulating our values. So at 2, since our starting point is at 2, there's no area accumulated right here. So g of x is equal to 0. Between -2 and -1, we have a +1/2 that's accumulated. And then at 1/2, we start at 1/2, and then we add that negative triangle. So it's 1/2 plus -0.75. So the total accumulated area is -0.25. And then we need to accumulate a little bit more here. So at 5, we're starting at -0.25. We add the area of that green triangle, and then we add the area under the quarter circle, plus 9 minus 9 pi over 4. And when we're done with the arithmetic, we get that's 11 minus 9 pi over 4. And if you want to approximate, 9 over 4 is 2.25 times 3-ish. 2.25 times 3-ish is only around 7. So this number is around 4-ish. So out of all the 4 values, we can see that the absolute maximum occurs at the end. So the absolute maximum value, notice when the question is asking for value, they want the y value. So we can say something like this: the absolute maximum value of g is 11 minus 9 pi over 4. Notice they didn't ask us for the x value, but we could say that it occurs when x is equal to 5. And then this whole table right here is acceptable justification for this question. So that's that. Part D is pretty straightforward. It's just asking us to evaluate the limit when x approaches 1 of this entire really weird looking function up there. So when we're evaluating the limit, the first thing we want to do is just directly substitute. And since I'm lazy, I'm just going to call this h of x, because I like the letter h. So we can say the limit as x approaches 1 of h of x is equal to 10 to the 1 minus 3 f prime of 1, all of which over f of 1 minus arctan of 1. So we have to use our graph a little bit to analyze. Let's figure out what f prime of 1 is. Well, f prime of 1 is what the slope is equal to when x is equal to 1. And notice that this is just a straight line, so I can just calculate the slope from this point to this point. It's up 2, it's over 1, so f prime of 1 is equal to 2. And then we also need f of 1. F of 1 is just the y value when x is equal to 1. Well, when x is equal to 1, y is also equal to 1. So then we can go ahead and start plugging in our points. 10 to the first is 10. F prime of 1 is 2. F of 1 is 1. And then if you remember your trigonometry, we know that the inverse tangent occurs when the radian measure is pi over 4. For those of you who need a quick refresher, pi over 4 is the same as a 45-degree triangle. And when you have a 45-degree triangle, your opposite is always going to equal your adjacent. Okay, so that's why this answer is pi over 4. If we simplify a little bit further, we get 10 minus 6 is 4 over 1 minus pi over 4. And on the AP Calc exam, it's okay if you leave your final answer in this complex fraction form, as long as your number is numerically equivalent. If you want to simplify a little bit further, you can, so we can multiply the top and bottom by 4. When we do that, we get our limit approaches the number 16 over 4 minus pi. And that's our final answer. All right, that's it for this video. If you have any questions, leave a comment below. Otherwise, if you like this video, give us a like or subscribe to our channel.